Back in August last year, astronomers around the world witnessed the momentous merger of two neutron stars. This unprecedented event was observed as a range of signals at once, including gravitational waves, light, radio and gamma rays, but the aftermath of the mashup HASNT played out quite as expected. Rather than fade out over time, the afterglow has continued to brighten over the past few months, leaving scientists stumped. The event, reported last October, marked the fifth observation of gravitational waves, ripples in the very fabric of space-time, caused by huge cosmic cataclysms. Previous detections had all been the result of pairs of black holes merging, meaning they were invisible to most instruments and only detected indirectly by facilities like LIGO and Virgo, purpose-built for the job. But this time the ripples were created by very visible neutron stars, about 138 million light-years away. LIGO was the first to detect the signals as gravitational waves, before 70 observatories around the world joined in to watch the fireworks in the form of visible light, radio waves, X-rays and a gamma-ray burst. But the story didn't end there. Continued observations have shown that the event is even weirder than first thought. Usually when we see a short gamma-ray burst, the jet emission generated gets bright for a short time as it smashes into the surrounding medium, then fades as the system stops injecting energy into the outflow, says Darrell Haggard, lead researcher on a new study describing the continued observations. This one is different. It's definitely not a simple, plain Jani narrow jet. Radio telescopes have remained trained on the site since detection, and found that the emissions weren't fading away as expected. To the contrary, they actually brightened. Unfortunately, the sun was photobombing that region for about 3 months, meaning optical and X-ray observatories weren't able to see what was going on. When the source emerged from that blind spot in the sky in early December, our Chandra team jumped at the chance to see what was going on, says John Ruin, lead author of the study. Sure enough, the afterglow turned out to be brighter in the X-ray wavelengths, just as it was in the radio. Astronomers are still trying to figure out what may be happening. One possibility that the new study raises is that the collision launched a powerful jet of material that shock-heated the surrounding gas given off at the same time, which continues to glow. Whatever the case may be, observatories will no doubt keep watching the skies eagerly. This neutron-star merger is unlike anything we've seen before, says Melania Ninka, co-author of the study. For astrophysicists, it's a gift that seems to keep on giving. The research was published in Astrophysical Journal Letters. View Gallery 2 images.